Jai Hind everyone. I am a Dr. Ashish Dixit. Today I will discuss about the topic of the big data analytics. Topic is a Hadoop distributed file system. So first of all, what is a big data? A big data is a technique or a technology that will be manage a huge amount of data in a proper order. So here we will apply a multiple types of techniques. In the multiple types of techniques, we have a study a topic Hadoop distributed file system. So here we will cover some topics. First, as the design of SDFS, Hadoop distributed file system, SDFS concept, benefits and challenges, file size, and block abstraction in SDFS, and data replication. And here I also discuss the how does SDFS store, read and write files. Okay. So here SDFS is a data set that outgrow the storage capacity of a single physical machine. Then it becomes necessary to partition it across a number of separated machines. So file system that manage the storage across a network of machine are called distributed file system. Suppose that we are given examples of the ATM machine. You know very well centralized server is a one and multiple types of machine, those are existed a different zone, different area. This concept is also called a distributed system. So next thing, a Hadoop comes with a distributed file system called SDFS, which stands for a Hadoop distributed file system. So SDFS is a file system that designed for storing a very large amount of data that will be processed, or we can say that streaming as a data access patterns running on a cluster of commodity hardwares. So a very large file in this context means that have a huge amount of million, trillion or a megabyte or a byte or a gigabytes or a terabyte in size. Okay. So what is the meaning of streaming of a data access? So SDFS is built around the idea of most efficient processing pattern in a written or a read. We can say that write on read many times pattern, many time patterns. So a data set is typically copied from the source, then various analyses are performed on the data set over time, we will use Apache Kafka, Apache Flink. These are supporting for a data streaming. During this concept, suppose that for execution of our program, we have a need multiple types of softwares that will be support for our support of our execution process. So we can say that these are commodity hardwares. Like Hadoop doesn't require expensive, highly reliable hardware to run. So here we will design on a cluster of the commodity, means commonly available hardware available in the form of multiple vendors. Suppose that we have given one example. We have a Apple laptop. You know very well the Apple laptop accessories will not be available in common places. We have a 2 to 3 or 4 multiple stores in one city. But if you can say that if you are a user Dell or a HP laptop, then you well known that multiple shops are also available, multiple types of vendors are also available for helping our problem. Okay, so this concept is called commodity hardware. Next, these are area where the HDFS is not good fit. First condition is a low latency data access. Here, ability of computing system network to provide a response with minimal delay. And second thing, application can require low latency access to data in the tens of the millisecond range. So here we will not work well in a SDFS, because second point, multiple types of file also available, they have in the form of shard. Means छोटे से जो छोटी फाइल होती है वहां पे क्या जो डेटा मिलियन एंड ट्रिलियन डेटा को हैंडल कर रहा है, इफ वी कैन से दैट इफ यू आर गिवन टू रिक्वेस्ट फॉर अ processing of mini data, then it's a very, I think it's a very critical condition that one process will be also handled for a huge amount of data, and you send the request for mini data. Means losses of supports hardware, supporting softwares, and timing process. Second thing, multiple writers, arbitrary files modification. So here, a files in HDFS may be written to be a single writer. So writes are always made at the end of the file. So there is no support for a multiple writers. For modification at arbitrary offset of in the file. Next, features of HDFS. So it is suitable for the distributed storage and processing. Hadoop provides a command interface to interact with HDFS. Command interface. Okay, so this is suitable for distributed storage and processing. Next thing, the built-in the server of the name node and data node help user to easily check of the status. Name node and data node. These are key point. Next thing, streaming access to file system. Without the streaming, it can't be possible that you will be access of any file. Okay. Next thing, SDFS provide file permission and authentication. SDFS provide permission and authentication. Always keep in mind, every database, if they don't want to give in a permission, then you can't access. First of all, this is the key features. Without the permission or without the authentication, you can't access any data. Okay. So here, this is the architecture of the SDFS. So always keep in mind, here we will discuss about the architecture. This is a secondary name node, and this is the backup. This is the backup of the secondary name node. We can say that checkpoints. And here we have a multiple types of audio files, video files, text files, images in this data. So here secondary name node send to the request to the name node for accessing or for managing of a data. So here a name node also have two types of management system. First called the namespaces and second called the block management, block map. Okay. So namespaces handle the request that will be sent by the name node, and name node given to instruction of the namespaces that how it will be handled. The namespaces handle whole information by the block management. Or here a block management that also do the concept of the block map. What is a block map? Always kept in mind, we have block management send the request by the block map for accessing our data node. And data node have different types of replicated file. What is a replicated file? A same file that will be exist in a multiple data node. Then this is called the replication. BL1, BL1, these are replicated. Second thing, BL2, BL2, these are replicated here. Okay, BL7, BL7, BL6, BL6. Okay, these are a replicated file. So, for a mapping of this concept, here we will map by the block mapper. Multiple types of files are replicated. So here it's a send the information to the secondary node. But here a name node also have a backup, meta backup. Name spaces, metadata, checkpoint and edit journal log. Okay, these concept is also arises by the HDFS architecture. So, okay, we'll send the again HDFS architecture. So here, these are a file system. File 1, file 2, this is the client, and client add the block in a name node. So here, these are data node. These are a data node. We can say that these are a heartbeat of the name node. Okay. So here, add the block in a name node. Here we will arises some points like node block name, mapping, okay, data block node, mapping, and name node, mapping. These are a node 1. No, we have a information node 1. Node 1 is this 1378. This is a node 1. Here the value is available. Second thing, node 2, 2, 3, 4, 8, 9. Then node 3, 1, 4, 7, 9. Okay, these are a node. Second thing, data to block of the mapping. Here, file 1, 2, 3, 4. 1, 2, 3, 4. File 1. Okay. Second thing, 7, 8, 9. These are file 2, 7, 8, 9. Means two file have some replicated data. That replicated data are exist in a file 1 and file 2. Here 1, 2, 3. Okay. And second thing, 4. Next thing, 7, yes, 7, 8 and 9. So here we are also access a checkpoint backup and disk based secondary name node. It's also provide a backup of secondary backup. Next thing, a Hadoop distributed file system that follow a master slave architecture. Each cluster comprises a single master slave architecture. Each cluster comprises a single master node and multiple slave node. So internally, a file get divided one or more blocks. Each block is stored on a different slave machine. So depending on the replication factor. Second thing, the master node stores and manages the file. Manage the file system, namespaces, and this information about the block of the files, like a block location, permission, and the slave node store the data blocks of the file. Then the master node is the name node and data node are the slave node. Okay, master node is the name node and data node is a slave node. Means this here, this is the data node and this is the master node. This is the master and this is the slave. Yeah, this one. Name node, this is the name node. We can say that master, and we can say slave. Okay. Next thing, HDFS name node, it manages the file system namespaces and provide the right access of the to permission to the client. Then name node stores the information about the block location, permission, and accessing. So here on the local disk, in the form of two types of files. First, FS images. Second thing, edit. FS images means file system images. Okay, so file system images are FS images that also have the collection of images, because images is also considered in a unstructured data format. Okay, so here we can say that file system images stands for the file system image. It contains the complete namespace of the Hadoop file system since the name node creation. Next thing, we can say that edit log. It contains all the recent changes performed to the file system namespaces to the most recent files images. Means we can say that it's the recent challenges to perform the file system namespaces to the most recent file system. So here we can say that these are edit files, these are files images. Okay, so we can say that here first role edit, that is new, then here edits and file system images. So here we can say that client send the information to the retrieve of the file images and edit from the primary. So we are use the edit and files images. Then after, in a files images and checkpoint also consider the FS images and edit. Then after, it will be transfer the checkpoint to the primary whole section. Then file system images also checkpoint. Then here we will be separated to the file system and edits. We can say that its process is called the role files images checkpoint and edits the new concept. So what is the function of the HDFS name node? So we can say that these executed files system namespaces operation like opening, remaining, and closing file directories. Second thing, a name node manages and maintain the data node. Okay, manages and maintains the data node. Next thing, determines the mapping of the block of a file to data node. Next thing, name node records each changes made to the file system name. Always kept in mind, if it will be changes, then definitely namespace, the file of the namespaces that will be exist is also changed. Then keep the location of the each block of a file. Okay. Next thing, a name node take care of the replication factor of all the blocks, and name node receive heartbeat and block reports from the data node. Always kept in mind, because name node receive heartbeat. Name node receive heartbeat from data node. Okay. Suppose that it's our human body, or if heart didn't beat, then our body will be dead. So always kept in mind, data node is a heartbeat, name node is a heartbeat of the data node. This thing. This thing. Okay. Name node is a heartbeat of the data node. Next, HDFS data node concept. A data node are the slave node in the Hadoop data node, and inexpensive the community hardware. They store the block of the file. Then function of the data node. Here we will use the function of the data node. Then data node is responsible for serving the client read and write request. Then data node based on the instruction from the name node, and data node perform block creation, replication and deletion. Then next thing, a data node send the heartbeat to the name node to the report of the health of the SDFS. Because the work of the data node, SDFS, we can't judge the SDFS work properly or not. Next thing, a data node also send the block report to name node, report of the list of the block it contains. So here we can separate the name node and secondary name node. Secondary name node. So here these are a name node. These are also having files like edit and files images system. Okay. So here the edit and file images system, new, send to the new, edit new, then edit and file system. So here we will send the request for download files images edit to the name node to the secondary name node. Then after sending the request, it provides the response to the query name node for edit the logs, then download the updated edit log. So here we will take the copy updated files images back to the name node. So here use the secondary name node is also having the same structure, edit and the file system. It also applies the edit logs and files images and also store in the files images new concept. So here we will use a client, name node and secondary, because name node also have a data node. Okay, also have a data node. If we can say that data node is a heartbeat of the SDFS. If a data node send to the information of the name node, then name node realize and send the information that our SDFS work properly. Okay. So these are can say that checkpoints. The checkpoints name node is a node that periodically creates checkpoints of the namespaces. Checkpoint node in the Hadoop first downloads a file images and edit from the actives name node, then it merges then files images and edits. So next thing we can say that store that at least checkpoint of the directory that has the same structure of the name node directory. Okay. So we have also available a backup node. We can say that backup, because of without backup it's can't be possible that our software will work properly. Suppose that immediately we have lost some information, then we can set the command of the commit or a backup, then or a rollback, then it will be available in a same position. Okay. So this is the concept of the backup. So block size data blocks in a Hadoop SDFS, always kept in mind that customized block is 128 MB. We can say that if we use a huge amount of data, suppose that we have a 612 MB, then it's a very good approach. It will be split in a 128 MB. Then here we will use a 128 MB. Then after 128 MB multiply 4 and remaining is 100. Then we use 128, 128, 128, 128 and 100 MB, because 4 blocks is use 128 MB and remaining blocks, remaining data size will be used in a D. So this is the customized block size. So here I also mentioned that the SDFS is split the file into block size called a block. The size of the block is 128 MB by